Lesson 7.4, Purchasing a Home. Please read the introduction article, What Will the American Dream Cost You? So you're familiar with the terminology that we will be using in this lesson. Example 1. Leah and Josh are buying a $600,000 home. They have been approved for a 3.75% APR mortgage. They made a 15% down payment and will be closing on September 6th. How much do they expect to pay in prepaid interest at closing? So the very first thing that we need to figure out is how much are they actually putting down? We know that they are doing a 15% down payment, but how much money is that? So it's 15%, and it's 15% of the entire purchase of the home, which is $600,000. 15% of multiplication, $600,000. You can't use percent, so you're going to change it to a decimal. So we have 0.15 times 600,000, and if you multiply these together, you end up getting $90,000. So they put down $90,000 on the purchase of their $600,000 home. Well, if that's how much they put down, how much do they need to borrow now? So to figure out how much they're borrowing, you need to take the cost of the house and you need to subtract the money they already put down, which is called the down payment. So the home was $600,000 and we've already put down $90,000. So how much is left, which they are going to need to borrow? It is $510,000. So that's how much money they need to borrow from the bank. So how much do they expect to pay in prepaid interest at closing? If we're going to be looking at prepaid interest, we need to look at their closing date and when is the date of their first mortgage payment. So they closed on September 6th. If they close on September 6th, that means that their first mortgage payment doesn't happen until the first of the next month, which would have been October. So from September 6th to October 1st, how many days is that? Because that determines how much prepaid interest they're going to need. So between September 6th, which means September 7th, and October 1st, which is September 30th, so between these two. So from the 7th to the 30th, they need to pay interest in all of those days that the house is theirs, but they haven't made a mortgage payment yet. Counting these on the calendar, there are 24 days in which you need to pay for your prepaid interest. So the question is, how much interest do we have to pay for those two? To figure that out, first you need to figure out your annual interest rate. So our annual interest, to figure that out, you're going to take the cost of the loan and you are going to multiply it by the APR because the APR is your annual interest rate. So the cost of my loan, we said that we were going to be borrowing $510,000. The APR in a decimal is 0.0375. Multiplying these two together, I end up getting $19,125 as my annual interest. But I'm trying to figure out what the interest is for 24 days, not annually. So if this is my annual interest, we can use this to find our daily interest. So if I take my annual interest and I divide it by 365 days, because that's how many days are in a year, I'll be able to figure out what the cost is daily for my interest. So my annual interest, we said, was $19,125. Divide that by all 365 days out of the year. We end up getting 52.39726, which we are going to round to be about $52.40 per day in interest. So we need 24 days of this payment. So how much interest do I pay for those 24 days? So we have 24 days worth of interest we had to pay for at a rate of $52.40 per day. Multiplying these two together, I end up getting $1,257.60. This is how much prepaid interest they're going to do. And that's the prepaid interest because they have not paid mortgage from September 7th to September 30th. Now let's go ahead and check your understanding. How much will be charged in prepaid interest on a $400,000 loan with an APR of 4% that was closed on December 17th? So first, how many days are we going to have to pay prepaid interest? How many days? So if we close on the 17th, that means that our prepaid taxes, they start the next day, which would have been December 18th, and they go for the rest of the month, which would have taken us to December 31st. Counting on your calendar, 18th to the 31st gives you a total of 14 days. So we have 14 days in which we are needing to pay prepay interest. Well, so we need the daily interest rate. Because they gave us an APR, we know our annual interest rate. So first, let's go ahead and figure out our annual interest rate so we can use it to figure out our daily interest rate. So my annual interest is going to be the cost of the loan. They told us we are borrowing $400,000. And I'm supposed to multiply it by the APR. So 0.04 is my APR. Multiplying these together, I get $16,000. But this is my annual interest. I needed daily interest because I only want 14 days. So if I take my annual and divide it, there's my annual, divide it by the 365 days out of that entire year, and we end up getting 43.8356, which we're going to round to about $43.84 per day. And this is how much interest they are paying per day. So if I have 14 days of which I am paying this, how much am I paying total? Multiplying these two together, I get $613.76. This is how much prepaid interest I am paying for the rest of December. Example number 2. Leah and Josh know that they will have to bring their checkbook to closing with them. What might they expect to pay in total at closing? So we have a general rule of thumb. And the reason why it's considered a general rule of thumb is because we don't have any guarantees. It all depends on what gets happening in the signing. So the general rule of thumb is that your closing costs are going to cost between about 2 and 6% of the purchase. So we have 2 being the smallest percentage and 6 being the largest percentage. So let's go ahead and look at your 2%. If I'm doing 2% of the purchase price, my 2% closing costs would be, here is my purchase price, and I am doing 2% of the purchase price. Multiplying that together, I get $12,000. This is the minimalist amount of money that I will need at closing. 6% being the highest amount that I would possibly need for closing. So it's 6% of this purchase price. 6% of that purchase price is $36,000. So how much might they expect to pay in total at closing? Between $12,000 and $36,000. Now let's go ahead and check your understanding. Charlotte has to make a down payment of 15% of the selling price of her house. She was approved for a $340,000 mortgage. What range of costs might she expect to pay at closing? So she's already paid her down payment of 15%, already did it. She was approved for the remaining portion of the house. So the bank approved the remaining $340,000 of the loan. So if she already paid 15% for her down payment, that means the bank is going to be providing her with the remaining portion of the bill, which would have been your thought bubble here, your 100% of the bill minus you paid for 15% of the bill. The bank is going to pay the other 85% of the bill. So the bank is providing the rest of the loan, which is going to be, we were told, $340,000. And we know that that is actually 85% of the actual home price. So you paid for 15% of the home. The bank is paying the other 85% of the home, which just happens to be $340,000. So the question is, what's the actual price of her house? So we only know 15% of the down payment. We don't know the down payment and the percentage. But we do know the percent the bank paid and how much the bank actually paid. So because we know these two values, these are the two values we're going to end up using. So I know 85% of the house is what the bank is paying, and the bank is actually paying $340,000. Now I just need to figure out the price of the house. So since these are connected by multiplication, you undo multiplication by dividing. So I'm dividing both sides by 85%. So the cost of the house, $340,000, divided by 80%. Remember, your percent needed to be changed to a decimal, so it's 0.85 on your calculator. So $340,000 divided by 0.85 gives me $400,000. So this is how much the house actually was purchased for. If this is how much the house is actually purchased for, that is how much is going to be used when you're considering how much to charge for closing. So remember, closing is going to be between 2 and 6% of the house purchase. So 2% of the house purchase, so here is 2% of means you're multiplying. We just determined our house purchase was $400,000. This would have been $8,000 worth of closing costs. That's the lowest end. Well, what is my highest end at 6%? So here is my 6% multiplied by the cost of the house. This would have been $24,000. So my low end and my high end for my closing costs. So what are the closing costs? It's going to be between $8,000 and $24,000. Example number 3. Trudy and Tom have been approved for a $300,000 15-year mortgage with an APR of 3.98%. How much of their first monthly payment is going to go to interest? And then how much of that first monthly payment is actually going to principal? Every single one of your payments is a combination of interest and principal, and it's actually not the same every single month. So how much money out of that monthly paycheck is interest versus how much of that monthly payment actually is principal changes every single month. At the very beginning of your payments, your interest is really high and your principal is really low. And as you get through on your payments, as you get closer and closer to the end, by the end of the actual payments, your principals are going to be most of your paycheck and the interest is going to be less. So it starts high and your interest ends up being low. Principal starts low and then it ends up being high in the end. So most of your payment at the very beginning is going to be mostly interest. Your last payment, most of your payment is going to end up being principal. So I just want to know how much is actually going towards interest and how much is actually going towards principal. So the very first thing that we need to do is we need to look at a new formula. This is our monthly payment formula. And this is new because you will notice that we will be using our R's as the actual percentages, not turning our percentages into decimals. We're keeping them as the actual percentages. So our M stands for our monthly payment. Your P still stands for how much you're borrowing, your principal. Your interest rate is going to stay as the percent. We're not changing it to a decimal this time. And then T is going to be the length in years. So based on the problem we were given, we don't know our monthly payment. That's what we have to figure out. They are approved for an entire $300,000 payment, so that's how much they're borrowing. The rate is 3.98%, and we're leaving it as a percent. And T, it said it was a 15-year mortgage. So I don't know my M. I do know my P, my percent divided by 1,200, my percent again divided by 1,200. My exponent is 12 times 15, all divided by my percent divided by 1,200. My exponent is 12 times 15, and that entire thing is minusing 1. You are going to type this in exactly as it reads into Desmos. A graphing calculator, you risk the chance of getting something in the wrong position. Desmos will allow you to see the way you actually type it in. And when you type this into Desmos, you end up getting the answer of 2216.05823, which we are going to end up needing to round. So we're going to round our monthly payment to be about $2,216.06. So this is our monthly payment. But that wasn't the question. The question asked how much of this is interest and how much of this is principal. This is what you're paying guaranteed every month. So first, let's figure out how much of this is actually going to be interest. And again, we have another new formula. The I is going to be your interest, your P is your principal, and R is going to stay as the interest rate but written as a percent. So according to our problem, we're actually trying to figure out the interest. We don't know what that is. The principal said that $300,000 is how much we were borrowing. My rate is my interest rate, which was 3.98%. Typing this into either your calculator or Desmos, you end up getting that $995 is how much that I need to pay to interest. And this is based off the fact that there is still $300,000 left in principal. This interest amount will change every single time the principal changes, which means every single time you pay a payment, this principal is going to change, which means this changes. So this is how much I'm paying in interest, but that's just for that 1 month. If that's how much I'm paying in interest for that 1 month, how much am I then paying in principal for that month? $1,216.06 monthly for my payment. I know my first month's interest is $995. So that meant whatever was left of that paycheck or that payment is my first month's principal. So I ended up paying $2,216.06. Of that, $995 of it belonged to interest, which meant the remaining of it is going to end up being principal. So I am paying $1,221.06 to principal. So this is how much went to interest, and this is how much went to principal, and that's just month one. It'll change every single time based on this formula and how much principal is always left. Now let's go ahead and check your understanding. In the problem that we just did, we learned that you are paying this much every single month. Of that one payment, the first month has $995 of it going to interest and $1,221.06 of it going to principal. So for your first month, how much then is going to interest percentage-wise, and how much of it is going to principal percentage-wise? So I paid $995 of those dollars to interest, and that was out of the entire $2,216.06 of the payment. This amount of that payment ends up being 0.448995, which if we rounded that, tells us that we rounded it and we're going to give us a percent. So this is 44.90% of your first month's payment went to interest. Well, then how much of it went to principal? So I know that I had $1,221.06 out of the entire $2,216.06 was my principal. This as a decimal is 0.551004. Turning it into percent and rounding, this is 55.1% of your first payment going to principal. So again, the percentage is going to change every single paycheck as you pay down your principal. But of your first bill, 44, almost 45% of it is going just to interest to allow you to borrow the money, and 55% of it is going to actually pay down the cost of the house. Example 4. How can Trudy and Tom get an accounting of their monthly payments and how they will be divided for the first year of their mortgage? So they wanted to look of those monthly payments for the first year, how much of it is interest and how much of it is principal. To be able to look at an entire accounting of it, we are going to need to make a Google Sheet. And on that Google Sheet, we are going to make an amortization table. And on the amortization table, what is that? The amortization table is a breakdown of the list of your unpaid principal, how much you pay every month, and then how much of that monthly payment actually went to principal and how much of it actually went to interest. So there's a couple of questions we need to ask ourselves first. First, what is the basic mortgage information? Because that's what we need to type into our Google Sheet first. So our basic mortgage information includes the principal, the interest rate, and it's important that we know that this interest rate is written as a percent, the length of the loan, and formatting these so it's easier for us to see. So what is this information? I know that the principal was $300,000. I need this to be written as money, so we need to hit the money button so they register it as money. My interest rate is 3.98, and we're not going to put it in as an actual percent. This is the percent. If we make it do the percent sign using the percent button, it's going to do something different to it. We don't want to do that. What is the length of the loan? The length of the loan is 15 years. Next, what do you want to know? What do you want this Google Sheet or this amortization table to tell us? What we want to know is what is our payment number? So is this the first payment, the 7th payment, the 12th payment? What payment is this? Beginning balance, our monthly payment. We want to know how much money we paid that was towards interest, how much money that we paid was toward principal, and we want to know our ending balance. How much is still left after we paid everything? We need to format these, so I'm going to bold both of them. I am going to center them, and I'm going to have them all wrap text, so everything will fit. Next, we need to know what our monthly payment needs. It first needs this equation, and you are typing not values into these variables. Instead, you are telling the Google Sheet what cell to look at that represents these. So we wanted to figure out our M for us. Our principal, we see, was on B1. So every time the P is there, we're going to select cell B1. Our rate, we had put it into the cell B2. So wherever there's a rate in the equation, we're going to end up hitting the B2 cell. And our time, we ended up putting it in the B3 cell. So every time we need the time, we need to make sure that we select the B3 cell. So our payment number. On our first payment, what are we doing? Our balance starts off at $300,000. So our balance starts off at the principal. What is your monthly payment? Our monthly payment is going to be the same every single time. And this is an equation. And so in this cursor up here, I'm going to put the equal sign. We have a numerator and we have a denominator. We have a fraction. So inside the numerator, I observed that I had the value P, which I'm going to put in a parenthesis. I am going to multiply that by the second parenthesis that I have, which is R, all over 1200. And I'm going to multiply that by the third parenthesis that I have, which is the 1 plus R, all over 1200. But that last parenthesis is raised to an exponent. And I'm going to put that exponent inside a parenthesis as well. Organizing it with these parentheses helps me to see what's happening to my fraction. The first parenthesis is the P, the principal. What is the principal that we are having to pay on every single time? It is this $300,000 principal. And so I'm going to click right there. It doesn't change. It never changes. And if I don't want it to change, then I need to put the dollar sign around the B to say, hey, this is my principal, and this will always be my principal. This value inside of this parenthesis will never change. That's what the dollar signs mean. Our second parenthesis is supposed to be our rate, which is this. So I'm going to click on there. And our rate is divided by 1200. My rate is also never going to change. This will always be my rate. So I need to put dollar signs around the B so that you can see it is never going to change. Our second parenthesis is a 1 plus my rate, which was this cell right here, divided by 1200. Again, the rate is never going to change. The rate's always going to stay the same. So we need to put dollar signs around that B saying, hey, he's never changing. He'll always stay the same. And then this was supposed to be my exponent. It's 12 times my length of the loan, which is T. So clicking at T, the length of the loan is never going to change. It's going to stay the same. So we are going to put parentheses around the B to say, hey, you're never going to change. This is my entire numerator. If I want to keep the numerator all in the numerator, I am going to put parentheses around this, saying, hey, all of this was my numerator. And now I'm going to go ahead and divide. And what am I going to divide? I know in my denominator, there was a parenthesis raised to an exponent, and then I was supposed to subtract 1. That was my entire denominator. If I want that to stay all in the denominator, I need to put parentheses around the whole thing, saying, hey, look, this whole thing was in my denominator. My parenthesis was a 1 plus my rate, but my rate is not moving. So remember, we need to put parentheses around the B to say, hey, I'm not moving. That rate was supposed to be divided by 1200. And then this other parenthesis was actually my exponent. This is 12 times my length of the loan, which is also never changing. So the length of my loan is dollar signs around it. I now have my entire numerator in a parenthesis divided by my entire denominator in a parenthesis. I'm going to go to the end of my problem and I'm going to hit enter. This is my monthly payment. And this is the monthly payment that we will always have no matter what payment number we are on. So now let's go ahead and look at the towards interest. For the interest column, we need to use the interest formula. And this was the interest formula that we just learned about. The interest is what we need it to calculate. Our P, our principal, is changing every single time we make a payment. So we need to put it as B6 because that is the new starting balance. R is going to be B2, but I don't want it to move. So I started off at B6, but when I go to the next row, I want it to move in B7. The next row, then B8. It needs to represent the new starting place. So this is going to change every single time. This is not. My rate is never changing. So I'm going to select B2, but I'm going to put these dollar signs in between the B and the 2 and at the very beginning because these dollar signs say, hey, don't move. B2 will always stay as B2. The fact that this doesn't have dollar signs means when I drag my formula to go into other cells, it's going to use another cell for me. This is what I paid on that month. Depending on what payment number it is and how much balance is left will determine how much my interest is on this problem right here. So we are going to do equal sign because this is going to be another formula. Your interest is all dependent on what your current balance is. And this current balance actually changes every single time. You're always having a new balance after you've paid something. So this is going to change, which means the B6 does not get dollar signs around it. But that B6 was multiplied by a parenthesis. And in that parenthesis, we had our rate, which your rate always stays the same. So we're going to put our dollar signs around the B saying, hey, that rate wasn't going to change. But that rate was supposed to be divided by 1,200. This right here is supposed to be what the principal is that we are using to calculate interest. That is always going to be the remaining balance on your loan. The rate never changes, and the equation had 1,200 on it. So let's go ahead and hit enter. And this is how much I am paying towards interest out of this payment. Well, if that's how much the interest was, let's figure out a principal. So equal sign says, hey, I'm going to give you an equation. This right here is how much I paid. And if I took out how much of that was interest, I will get my new principal amount. Now, why did I not put dollar signs around these? It's because my interest is always going to be changing. So I want it to be this cell minus this cell, this cell minus this cell, this cell minus this cell, all the way down. And that will tell us what our principal is. Well, what is our ending balance? The entire time, we're trying to pay off this balance right here. The only thing that affects this balance right here is our principal. So equal sign says, hey, equation, you started with the beginning balance, and the beginning balance is always going to change. So we're not putting dollar signs around it. I want you to subtract whatever I paid towards principal. And this is not going to get dollar signs around it because it's always going to change. Hit enter. And I now have my ending balance. This was for my first payment. How do we make this easy to figure out the rest of the payments? So if this is payment 1, this is payment 2. How do I make the computer know that this is going to be the next payment? You're going to say, please take the payment previously and add 1 to it. That will tell me payment 2. If you click on payment 2 and see this little cursor right here, if I drag the cursor down, it will continue to populate that formula. It will go to the one above, add 1. Go to the one above, add 1. Well, we're only looking for the first year. So let's go ahead and only do the first 12 payments because that would be the first year. Now, what is my new beginning balance? My balance is the previous ending balance. So we're going to hit equal and say, hey, my new beginning balance was the ending balance that I just figured out. And I'm going to hit enter. What is my monthly payment? My monthly payment's always the same. It was this formula right here. So if I drag that down, I will have the same amount every single time. The interest formula, the way that we typed it in, it has the dollar signs around the things that are not moving. And if we were to drag this little guy down, it knows that the B6, which is right here, will always go down and get the next one in the cell. So if I drag these down, now why are these zeros? It's because currently it doesn't have a balance because this needs to come from the guy that was over here originally. So as soon as we find these will populate, which would then populate this. I need to know this ending balance right here before I could figure out my new beginning balance. So how much of this was principal? The formula we typed in is set appropriately to say, take the payment and minus the interest. Take the payment minus the interest. So if I grab the little cursor and drag it down, it will know that it's payment minus interest. Because these are still zeros, because we don't know these are currently not accurate. We need to finish the rest of the table. My ending balance. Ending balance said, take the beginning, subtract principal. So it's always going to take the beginning, subtract the principal. Take the beginning, subtract the principal. So if I drag this down, it's going to know, take the beginning, subtract the principal. So now that we have all those, let's go ahead and drag down and you'll notice everybody repopulated. So this is what it goes for an entire year, our first 12 payments. So on my 11th payment, I still owed $287,605.55 on my house. My payment never changed. I'm still paying $2,216.06 every month. How much of that went towards interest on month 11? $953.89 went towards interest on month 11 because it was based on this is how much I still have left to pay. Then that meant $1,262.17 of that payment went towards principal. So if that's how much I paid off of this loan, what do I have left? I have this. That ending balance is the next month's beginning balance. And you could continue this on, and you could find out how much it would be after 4 years, after 10 years. Because these are all formulas, we could drag them down. And you could repopulate, and you could find any number of payments. 15 years worth of payments, you could drag this all the way down to 15 full years, and you could find the 15th year, the 180th payment, if you really wanted to. Now let's go ahead and check your understanding. If we added a cell at the bottom of the monthly payment, the toward interest and the towards principal columns, we would have found that after 12 full months of payments, this is how much money I paid. After 12 full months, how much interest did I pay? I paid this much interest. And after 12 full months, how much principal did I pay? I paid this much. So this is how much money I turned over. Of that money, this is how much of it went to interest, and this is how much of it went to principal. The question, at the end of the 12-month period, what percent of principal had actually been paid off? So I see that I paid this amount of money the entire time. I see only this amount of it went into principal, but how much was I owing the entire time? So now I know that my loan due, the entire total of my principal, I owe $300,000. How much of that have I paid down? I've only paid down this much. I've only paid down $14,922.97 of that $300,000 that I owe. So what is this percent? So I paid this amount of this entire bill as a decimal. That is 0.04974. It asks for the percent. So we're going to move the decimal to the right, and we're going to round. So it's 4.97%. I only paid about 5% of the entire bill after 1 year. And why was it only 5%? It's because the first few payments are higher in interest than you would think. Example 5. Trudy and Tom decide to make an extra payment of $100 every single month to reduce the principal. So they're not only going to pay whatever their monthly payment is, they're going to pay $100 on top of it. So you will notice this extra pay extra column that is right here. They adjust their spreadsheet as shown. What formula changes did they make in row 6? So here's row 6. So this is the row that we are looking at. So in this row right here, what did they change so that this extra payment was accounted in the rest of it? So this is how much we paid, but that's only what we were told to pay. We paid this much on top of it. So we had to add these two together to figure out how much we were really paying in the end. But this 100% goes to principal. So we notice that this principal, every single one of these, is $100 more than the previous sheet when this row didn't exist. So not only did this get $100 higher, that also meant that this was $100 lower every single time. So because they guaranteed paid $100 more, that guarantee goes 100% to principal, which means that guarantee takes it off of whatever the balance is in the end. It's 100% principal. Now let's go ahead and check your understanding. Examine the loan summaries here for the two situations that we looked at. Either you do not pay the extra $100 or I did pay the extra $100. How much interest and loan time is saved because we chose to pay the extra or didn't choose to pay the extra? You will notice, okay, so actual payments. Comparing the actual payments and comparing our actual interest. Because it asked, how much interest is saved? So total interest, comparing our interest, and how much time was saved? The payments is how much time is saved. So looking at our payments, our time. I paid 180 times if I did not put in the extra. but I only paid 170 payments if I did put in the extra $100 every time. So that means we saved 10 payments. So you could be done with the loan 10 months sooner because you put $100 extra in every single time. Well, what about your interest? How much interest did you save by putting $100 in every single time more? So without the $100 extra every single month, this is how much interest I paid over the lifetime of the loan. If I did pay $100 every single month, this is how much interest I paid over the lifetime of the loan. So what is the difference? The difference is $6,185.60. This is how much money I saved and held on to because I chose to pay $100 extra every single month. So I paid exactly what they told me to, but then chose to put an extra $100 in it. That extra $100 let me complete my payments 10 months quicker and allowed me to save $6,000 extra.